Thank you. Thanks, everyone. Thank you for coming. I'm largely focused on computer vision these days, and computer vision has taken over has been taken over by machine learning. And you might ask, what is computer vision? It's sort of taking this problem of the previous speaker was watching a lot of YouTube videos. This problem asks, what if instead of a human watching a lot of videos, we task computers with doing that instead and having it in some ways be automated, having the scanning and looking at vast quantities of video be automated in a way that you could perhaps watch all of the TV channels in the world all at once, or perhaps go through and look for particular things in all of YouTube. Things like this become enabled by computer vision. And so it's a very much related topic, so I'm glad that we're going one after another. Before I do that, I want to tell you that this is all largely new technology. So deep learning and machine learning have enabled us to do this in a way that was not possible before, where by looking at a scene here, we can tell that it's not just a bunch of pixels, each of which have different colors, and just display the colors, tell the projector to display a certain color at a certain 2x and y coordinate, but rather understand that there's a scene here with people in it, and some chairs, and a podium, and a table, and a cameraman. And all that is totally blind to a computer, only up until 4 or 5 years ago with deep learning and machine learning and coming into the mix. So what I'd like to do is very, very quickly give you a high level of neural networks. Hands up, who knows what an artificial neural network already is? And hands up, how many of you have trained one? Wow, okay, so actually something like 4 or 5 people have trained one, and then maybe half of the folks in the room have at least some familiarity with it. So I won't take much time then and to go deeper into the computer vision. So as many of you know, a typical machine learning pipeline looks like the following. There's some data. The data then gets fed into a learning algorithm which trains a model. The model is then usually replicated and served to many computers, where it acts on future data that hasn't been seen before, and it makes predictions. So, and then the entire pipeline is repeated. Each one of these little text boxes has an entire community of researchers behind it. Every single text box, like just managing terabytes of data, petabytes of data, has entire conferences, thousands of computer science researchers behind it. Figuring out what learning algorithms we should use, hundreds of thousands of machine learning researchers behind it. Figuring out how to store training models, thousands of researchers. Serving models, thousands of researchers. Each one is a cottage industry. And as each of these parts become more and more refined, we get to attack harder and harder machine learning problems. These problems are of the form, show me something on a screen, and then predict what am I looking at. Am I looking at a cat, dog, etc. So what I'm going to do is I'm going to zoom in on just one of these boxes, which is looking at trained models, and a particular model that we train is a neural network. So a neural network is in this process as one of these text boxes. It's one of the possible options in these text boxes. And so this is a very much a narrow view of machine learning. However, neural networks seem to be taking a lot of attention these days, so let's see what they do. So a typical computer vision neural network follows the following pattern. There's a picture here, and it's supposed to detect which of 4 things that picture is. Dog, cat, boat, or bird. And what the neural network will do is it will slide a small patch of numbers across the color values in the image. So it will say, look, I don't know what, there's a color value for here, and here, and here, and here. And it will have a lot of numbers by which it will multiply the color values. And it will add all of those multiplications up and feed that into the next layer as the input to the next layer. It seems kind of weird. You're just sort of multiplying numbers by the values, multiplying numbers by the color values, and propagating that to the next layer. And then in the next layer, you do the same thing. You slide a patch over this thing that is now not an image. It's some kind of averaging of the original thing, and then you do it over and over and over again. And the numbers that you multiply by you don't actually know what those numbers are. Those are called model parameters. They're unknowns. You don't know what they are, but somehow you hope that this is going to work. It's kind of weird, right? However, even though these are unknown numbers, these unknown numbers can be set by looking at data. So I have a lot of unknown numbers, perhaps a million unknown numbers. These are numbers that are being multiplied and added up using the color values of the original image. I don't know how to set the numbers, but I know how to get a gradient with respect to the numbers. What am I talking about when I say gradient? It's the same gradient that you saw in high school. The gradient of a function like x squared, right? The gradient of that function, you know how to get it. The gradient of a number that we're multiplying in this giant mess of math, we don't really know what it is, but we can compute it computationally. And using that gradient, we can actually set all of these unknown numbers. So there's like maybe a million knobs that we don't know how to set, but we can set them by using the gradient and using the gradient on data. Lots of examples of this tagged with there's a dog or a cat. We then set all of those numbers, and we call that training a neural network. This is an open. I'm not obviously going into the nitty-gritty details. At a very high level, this is the training process for a neural network. It's essentially been the revolution that we could train these and train them at a very high scale. We can do it with millions of unknown numbers and potentially billions of unknown numbers. So it's sort of like all of those unknown numbers are little connections in the brain, and we don't know how to set them, right? So instead we build something that can set them by looking at data. And so this is why it is the word artificial neural network. It's supposed to mimic somehow a neural network. Lots of debates about how much that's a true analogy. Now, we use that. This thing can now tell whether every frame is a cat, dog, or whatever else. Now we're going to step back from the engineering and actually start looking at the applications. So what can I do with this? I can now take this neural network that has been trained and retrain it and run it on all of YouTube, run it on all TV channels live. And here what I have is a detector which has an underlying neural network. This detector could be like one of the few things. And then we have video streams. These video streams are going to have a neural network run on them, and they're going to be monitored 24/7. So this is where it actually suddenly becomes very much applied. So all of if I lost you in the neural network mess, please come back now. So this is simply a TV channel like Bloomberg being monitored 24/7 for various things happening, like some objects, the genders of people that are showing up on the TV stream, and the faces of the past 4 US presidents. And I actually have a bunch of live demos for you in a second. So I'll go into this live because I have time. So Matroid is essentially a productization of computer vision with neural networks underlying it. So what we built is essentially a Photoshop for computer vision, where you don't have to program to get the power of neural networks for computer vision at your fingertips. You just build a detector for free. Everything I'm going to show you is free for like very, very simple use cases. And once you build the detector, you can then deploy it to monitor video streams, to socialize directions in video. These detectors are first-class citizens in Matroid, kind of like how Word makes documents and PowerPoint makes presentations. Matroid makes detectors. It's a weird thing. This is what happens when new technologies come along. We have to introduce some new terminology, so detector is our terminology. So you can create your own detectors by providing examples. So here I'm creating a detector for the face of Steve Jobs by skipping through some frames of Steve Jobs and then selecting particular frames that I think are of relevance. So I'm going to select this frame, and that frame. And then I'm going to upload these examples and hit create detector to create a detector for Steve Jobs' face. And then once I'm done with that, I'm going to be able to search for whatever my detector has been created to search for. So in this case, I created a detector for people, not any particular person, but people in general, and then I detected people in general. And so it's kind of boring to do this in slides. It's much more fun to actually do it in real life. And so what I'm going to do is I'm just going to go to matroid.com and start running things, right? So first things first is I'd like to let's look at existing detectors. So we're going to look at existing detectors on magechoice.com. So we can create a new detector, right? Or we can browse public detectors. I'm going to hit browse public detectors if my internet connection permits me, and then do I have internet?
Yeah, you did.
Well, it says here that I do. Okay, and then there we go. Okay, so I have a library of detectors ready to go, right? Let's say I pick up one of these detectors that I enjoy using, which is the everyday object detector. It can detect airplanes, bicycles, birds, and a few other things. And I'm going to run it live. Maybe I should put this by the door. If you pass this back there, this is my little internet thing. If you pass it to back there. Okay, so I'm going to run this, and I'm going to run it here, and we'll see what it thinks it's seeing. So what is it seeing? A lot of things. So it's saying there's a person there, a chair there, a person back there, a person there, another person there, and so on, right? Person there. So this is running live. Now, let's say I wanted to monitor a stream 24/7 for this. I would go and hit, say, I wanted to monitor Bloomberg, and I want to monitor Bloomberg for cars, for example. And then I say I start now and finish now. And what do I get? I get something that monitors Bloomberg 24/7, and this is going to be live, looking at Bloomberg for a bunch of things. I'm monitoring Bloomberg for emotions of people, happy, sad, surprise. Looking at it for objects, those same objects that I showed you earlier. And then the genders of people. So we're actually going to get a gender distribution for how often do men versus women show up on Bloomberg. And a bunch of other things like the faces of the past 4 US presidents, okay? So let's look at the gender distribution on Bloomberg first. Do you guys see this? Yes. So on Bloomberg, I'm going to get the gender I'm going to be able to pick out what is the gender distribution on Bloomberg. So if I were to say, wanting to check out what the gender distribution of the people in the videos that show up on the rant videos, I would be able to use this as well. But in this case, I'm going to be running it on Bloomberg because I did actually know what the previous talk was going to be. So this is going to be looking for faces that show up on Bloomberg, and then their gender. So there's a male there, a female, two males again, and so on, right? Female, female. And these are all fairly live. So this happened at 7:06 p.m. while I was here with you guys, with everyone here. And let's go to the very end of these detections. 7:51 p.m. So a minute ago, we had a male being detected and a female. So you can ask, okay, what is the general distribution here? And that's quite easy to get. For a detector that's been running, it's sort of just showing you live right there. It's male versus female. It's roughly 2-to-1. Bloomberg is a business channel. They seem to be heavily skewed towards females just showing up on their screen. This is anyone at all who shows up on Bloomberg, regardless of whether it's the host or a guest or anything like this. And if we go back to there, we could see things like emotions. So maybe we want to see all those rants, how many of them eventually at some point in the video had an angry person. I don't know if I'm actually monitoring for anger here. I'm monitoring for happiness, sadness, and surprise. So let's see if we had any of these emotions happening. We had a neutral face. Let's see. We had a sad face. He was pretty sad. And a neutral face there. And a person who's pretty happy there. And Putin, what's he looking like? Oh, he's just a male detection, right?
No emotion.
And so, you can see what's going on there. And the last one is the past 4 U.S. presidents. Of course, the current president shows up most often, and then like 7 o'clock, the current president showed up, right? And so sometimes you see previous presidents showing up, but most part it's the current president. Yeah, I actually have trouble finding previous presidents. Oh, there's Clinton, right? So he shows up in some kind of collage or something, right? So this is all coming from that jumble of numbers being added together, taking a gradient, the same gradient you saw in high school, using that gradient to fit these unknown numbers to some data, serving that model. There's a whole cluster of machines, hundreds of machines that go into monitoring all these TV channels, and then available to you without programming. So the sort of things that happen with this is archive.org, as an example, went out and monitored all the TV channels in the United States for political figures. And they ranked how often does Hillary Clinton show up versus other people in various news sources. They call this product the Face-O-Matic, and they built it with Matroid. Other things that we're seeing pick up is things like compliance, making sure construction workers are wearing their hard hats so that they're safe. No one's smoking in a gas station so they don't start a fire. In general, all Hollywood is an interesting customer of ours. They use it to just search all their past TV archives. You know, suddenly Trump became famous. It's very interesting to ask, where are all the occurrences of Donald Trump in Russian TV over the past 30 years? Right? And these are questions that can be answered now by flipping the computer to look at things that the computer has recorded previously. And hopefully automate some of video research that is going on in the world these days. In general, computers are opening their eyes, and there's way cooler things like we can now detect a lot of diseases automatically without the need for a doctor. So there are more subtle things that can be detected other than people's faces that will hopefully enable computers to essentially become an augmentation of every single medical imaging device that we have: X-rays, CTs, OCTs, and many other kinds of imaging. It's kind of silly that those things, they just give you a 2D or 3D pixel map of what's going on inside your body. Obviously, they should also give hints as to what they think is weird and potentially life-threatening, right? This just is stupid that you buy a machine from GE, costs maybe $1 million for an MRI, and then all it does is just gives you a picture of your insides. Of course, it should be telling you about anomalies that it detects with respect to the average person, so that at least a doctor can look at it and sort of say, oh, well, I don't think that's important, or I think that's important. So there's a lot of things we can go into, but I'd like to, sort of more geeky things, depending on, I don't know what the audience is like, whether you want to go deep into the math, deep into neural networks, or just sort of look at this implication. So I'd like to break here and start asking you what you want to hear about.